All right, this will be for the Khan Academy exercise quiz 1 and the unit logarithms. So for this problem here, we can use the change of base rule and go to the calculator, but they really want you to solve this by hand. Okay, so we're going to do it by hand manually. And what you can do for the answer here, you can just make that an X. And at this point, your best bet would be to change this from logarithmic form into exponential form. Now, it's easy to forget what goes where when you change from logarithmic to exponential form. So what I like to do is use one of the log cancellation properties. All right, and that log cancellation property is b to the power of log base b of x just equals x. And the way I'm going to get it into this form, and just before I proceed, because these bases match, the base b matches this base b, these cancel, and you're just left with the x, you're just left with the argument x. All right, we can do the same thing here. The base b has to match this base b. So right here, this base of the log is 81. I can make this expression the exponent on the number 81. Okay, and then on the other side of the equal sign, I can make x the exponent on 81. Okay, so I basically did the same thing to both sides, but I made these into exponents. Okay, this is 81 to the power of log base 81 of 3, and that equals 81 to the power of x. And now, just like I canceled here, I can do the same thing here. The 81 base matches this 81. These cancel, and we're just left with 3. And that's going to equal 81 to the power of x. All right. So basically, I took it from log form to exponential form. Do you have to use this method? No, not at all. If you know exactly what goes where, you just change it into exponential form. But I like to use log cancellation properties. Now, solving for x, what you want to do here is you want to match the base numbers on both sides. Now, you could use log properties and solve for this, but they don't want you to do it that way. They want you to do it by hand. Okay, so I want to convert the 81 into a 3. I know that 3 to the 4th power equals 81. Okay, so in place of the 81, let me make some room. I can replace 81 with 3 to the 4th. So in place of 81, that's going to be 3 to the 4th, and that is to the power of x, and that equals 3. Okay, when you have something with an exponent raised to another exponent, you just multiply, so that's 3 to the 4x. And of course, when a number has no exponent, it's automatically a 1. Okay, now that we have a 3 on both sides, we can match up the exponents. 1 equals 4x. All right, 1 equals 4x. Solving for x, the opposite of times 4 is divided by 4. So x just equals 1/4. Like I said, I understand you could solve this on the calculator, but that is not the point of this exercise. They want you to do it manually by hand as much as possible. So x is just 1/4. All right, in the box, 1/4. Okay, rewrite in the form of log of c. So in other words, combine these into one log. If you remember the log property for addition, you take the log of a plus the log of b, and that's going to equal the log of a times b. All right, I believe that's called the product property. So we can see that A is 5 and B is 4. This is just going to be the log of 5 times 4. And of course, that is just the log of 20. All right, so that's it. Log of 20. Pretty simple. All right, just type log of 20. You can put parentheses around the 20, but you don't need it. All right, table 1 contains outputs for f of x equals b to the x. Table 2 is outputs for g of x equals log base b of x. All right, so the point of this one is that this function and this function here, these are inverses. They're inverses of each other. This one is the inverse of g of x. This one is the inverse of f of x. So what happens with the inverses? Well, if you have x comma y and you go to the other function, it's going to be the same numbers in reverse, y comma x. All right, so the x value on this is the y value on this. And the y value on this is the x value on this. Okay, x, y, y, x, x, y, y, x. Same thing. Okay, so on table 1, this is the x and this is the y value. We are missing the y value at x equals 1. Okay, so you go to the other table and you want to look up the x value when y equals 1. Okay, here we're at x equals 1 and we want the y value. So we go to the other table, y equals 1, and we want the x value. All right, this is the y value. You go to y equals 1, and the x value is 2. So in that box, it's a 2. All right, notice it's reversed. X is 1, y is 2. X is 2, y is 1. It's just reversed. All right, and same thing here. Here we go to y equals 3, and we want the x value. So on this chart, we're going to go to x equals 3, and we want the y value. So let's do that. Here's the x. We'll go to x equals 3. The y value is an 8. Okay, and right here in the box, you just write 8. Pretty simple. 3 comma 8, 8 comma 3. It's just reversed. All right, we did one like this already. This is just going to be 3 times 5. So that's log of 15. And by the way, if this were a minus sign in the middle, it would be log of 3 divided by 5. All right, that would be the quotient property. If this were a minus sign, you would divide. But since it's a plus sign, you multiply 3 times 5 and you get 15. All right, another one of these, you want to do it by hand. Okay, I'm going to change this. We can make an X right here. I'm going to change this from log form to expo form. The base here is a 27, so I'm going to make this whole thing the exponent on the number 27. And I'll make the x the exponent on the number 27. Over here, the base is max, 27 and 27. Those cancel. And you're left with 1/3 equals 27 to the power of x. All right, usually you change the bigger number into the smaller number. So we have a 3 here. I can rewrite 27 in terms of... I can rewrite 27 as 3 to the 3rd power. Okay, and as far as 1/3 is concerned, that's the same as 1/3 to the 1st power. And if I take 3 to the 1st and move that up, that's the same as 3 to the -1. All right, so I can actually replace both of these and have a 3 on both sides. All right, so 1/3 gets replaced with 3 to the -1. And the 27 gets replaced with 3 to the 3rd. And that is to the power of x. Okay, and of course, like we said before, you just multiply the exponent, so that's 3 to the 3x. Now that we have 3's on both sides, 3 matches 3, you can match the exponent. -1 equals 3x. Solving for x, the opposite of times 3 is divided by 3. The 3's cancel, and it's -1/3. All right, so that goes right in the box. 1/3.